remarkable achievements and a deep commitment to technological innovation. So, ladies and gentlemen, please join me in warmly welcoming Dr. Sinnu Susan Thomas, a distinguished academic and innovator, as she shares her invaluable insights with us. So, put your hands together for Dr. Sinnu Thomas.
Good afternoon, everyone. I'm audible, right? So since morning, you are busy with the one after another, busy with all the lectures, right? So after post session, it's very difficult to keep the attention of the people, right? But I'll try my best to, communicate what I have in my pocket. So we'll be talking about condition generated. We'll be talking about condition generative models and how it is used in the computer vision, right? So since morning you're listening generative AI. I would like to know about the crowd. How many of you know exactly what's generative AI? Generative models, actually. You might have used ChatGPT. That's another thing. But how many of you know technical details about the generative models? Very few. So, right? Okay. So being a teacher and being a professor, so obviously our job is to take you from the bottom and take you to the level what we know, right? So I'll try my best to come up from the bottom and take you to the what is the latest development in the generative models. So basically, when you're talking about AI, right, there are basically two type of models. One is your discriminative models and another one is your generative models, right? So discriminative models, both these names, right, it's very usual from the names, right? So discriminative models means that discriminate between two stuff, right? So two things are there, assume two things are there. So how does it discriminate? That's the work of discriminative model. So basically, all of you know label data and all. See, I have used few terminologies which you may not be aware, you may be aware. So if you feel like that you are not aware of that terminology, please interrupt me in between, or we may take, in the interest of time, we may take the, concepts at the end. If anything I have used which is not anything, any terminology in this slide, which is not, which is going overhead. So please let me know, right? So discriminative models, right? So what does it do is it takes data, label data, right? And it tries to discriminate. Now you have apples and your oranges, right? So it discriminates whether which is an apple, which is an orange. If you give a new orange, right? So it tells you that this is an orange. So that's a discriminative model. Now it discriminates between different categories. So oranges and apples. So some of the examples of your discriminative models are, classical examples. Logistic regression. I'm not going in. This is not my topic, so I'm not going into into the details of all these models. So logistic regression, your support vector machine is here. Then you have your neural networks, right? So these are your simple discriminative models. What you hear. Coming to the generative models. Generative models means that tries to generate, right? The name itself suggests that it tries to generate, nothing else. It doesn't discriminate, but it just generates. Its duty is to generate. So it will generate based on what? What is it? What is the reference of generating that new data? Something has to be generated. So what's the reference for that? So, based on some description, some amount of, data or something, some metadata or something. Based on that, your model will try to come up with new information or new data, right? In computer vision, we are talking about, I work in the area of computer vision, I work in, ML, DL and reinforcement learning and so nowadays I've started with, explainable AI also. So, since my area is computer vision, so I'll be talking more from the perspective of computer vision. So, you try to generate new images, that's what we are doing in the generative models. So, some of them examples are your naive-based, GMM, Gaussian mixture model, HMM, all these models try to generate new data, right? So, apart from these models, there are, some of the new models which came into picture. Like, how many of you are perfect with, at least understand the term distribution, probability distribution? All of you understand distribution, right? Probability distribution. I'll take a little bit of math also. So, fine? Is it fine? Okay. So, now I'll be talking in terms of the probability distribution, how these generative models and discriminative models talk about the probability distribution. So discriminative models basically it just uses the decision boundary, right? It takes the decision boundary between two categories. So this is your decision. Does it work? Okay. So anyhow, fine. So this is your decision boundary, right? So it tries to generate two distributions. So one distribution is here, another distribution is right. So that's a distribution, that's basically the probability distribution of the data. That's what is your discriminative model going to do. Coming to the generative models, like it tries to generate, a distribution, a new distribution given on some basic inputs, right? So these are two different distributions, what is given to you, what is being generated from the generative model. Now the thing is, if you look at these two distributions, basically, what we are doing is we have some information in the beginning, right? And based on that, we are going to discriminate or we are going to, generate, right? So, basically, what we are doing is something is given to us and we are coming up with something new or some discrimination. So, that is condition, right? That's you're giving a condition, right? So what we are doing is we are trying to estimate the conditional probability, right? So you have a condition, based on that condition you will be coming up with the whatever your output, your label or whatever. So input is given to you and you are finding out the label, why, right? So in both these, discriminative as well as the generative models, you are coming up with, different probabilities. Now if you look here, in the generative model, it seems to something like, if you know clustering methods, right? Meaning clustering, a lot of clustering methods are there. So if you look at these two distributions, it looks like something like clusters, right? So, I can say that generative model is a sort of unsupervised learning. If I look at these clusters, yeah, right? Unsupervised learning, clusters are basic clustering, it comes under the unsupervised learning. So we can say that it's some sort of unsupervised learning. So basically in the generative and discriminative models, what we are doing is we are finding out the conditional probability. In both the cases, some condition will be given to you and you are finding out the conditional probability distribution. In the generative model, first we will be getting the joint distribution and from the joint distribution, we will find out the conditional distribution, okay, using your base theorem. Now, y given x. So, x is your data and you are finding out the label of the data. What is your data? So, that's your conditional distribution, conditional probability distribution. That is our job ultimately in the generative model or in the discriminative model. Now, that's what, see, generative model I said is an example of your unsupervised learning. Okay, it's just an example of your unsupervised learning. So basically what we are doing is, we are taking an input, training samples, right, from some distribution and trying to learn a model that represents that distribution, right? So some distribution of the data is given to you and you are trying to come up with a model that learns that distribution, right? So that can be done using two methods. If you want to learn that distribution, basically in the generative model, we are learning the distribution, right? So learning can be done using two methods. That is your density estimation. Again, probability density function, PDF, right? So you are estimating your density, and the second is your sample generation. You are coming up with the new samples. That is what are the two basic ways of generative modeling. Now, I'm not going to the map of all these things. So, density estimation, we are just estimating the PDF of the data, probability density function of the data. So, this is your data, and you are trying to estimate the density of that, distribution of that function, right? And sample is you have some training samples, and you are generating new samples from the training samples what you have. That's your sample generation. So basically these are the two ways your generative models work. Now if you look at ChatGPT, right, it tries to generate new data, right, based when it try to learns the distribution based on the distribution what was there about the data, right? So new things comes up. So basically generative model, there are three classes of generative models. That's the history how all these classes came. There's a history how these classes came. So first came up, autoencoders came up. Then you have your variational autoencoders. Then you have your GANs, generative or adversarial networks. Then you have your diffusion model. So I'll just brief you about all these models: autoencoders, variational autoencoders, GANs, and diffusion models. Coming to the latest, I'll end up with the stable diffusion, Cartesian stable diffusion model. So all these models are basically your latent variable models. Fine. You know variable models. What's a latent variable? You've heard about latent variable. How many of you have heard about latent variable? No? What I'm speaking, are you getting, or is it going over? Should I come down? Huh? It's okay? Perfect? So all these models, autoencoders, variational autoencoders, GANs, stable diffusion models, all these are latent variable models. I'll tell you what's a latent variable model. See, latent variable, I'll give you an example. You are working for a company, right? You are given some task and you perform that task. Some input you are given and you perform that task. Input is there, output is there. You do some processing, right? So everybody knows that some process is there. But behind that process, the way I solve it may not be the way you solve it, right? So there is some hidden thing behind that. Hidden may be my experience, right? My intelligence, my common sense, right? All those things are hidden. So the things which are hidden are called as the latent variables. Right? The variable, basically what is hidden is called as the latent variable. Right? So all these generative models basically work on the latent variable principle. They have something hidden behind the screen, and all these models work around that latent variable. So example is, which is a random variable which is not observed neither in the testing phase nor in the training phase. It's not defined, but the existence of latent variable is there. Fine. So latent variable example is what I said. Personality traits, how your personality is good. Because nobody knows, right? Nobody considers that in the output, right? Everybody looks at the result, right? But what is that all result came about as a result of our personality, our intelligence, right? So that's your latent variable. Intelligence, abilities, all those things are examples of your latent variable. So latent variable, basically these type of models try to recover those hidden personality traits, right? So these models basically try to recover those observed variables from the data. How did a person perform? What was his intelligence level when he tried to generate a new, when he came up with a new principle, when he came up with some output? So all these models, these generative models, works on the principle of they will try to come up with that hidden stuff, what is inside us. And basically, when you come up with that hidden stuff, so basically it reduces the dimension of your problem. So we all know that we will be working in the feature space, right? We have images, we have features in that, right? So images are full of features, be it images, be it your text, be it your whatever, video or your speech, any data, right? All those data has some features, right? So we are working in the feature space and we know feature space is very high, right? So feature space we can take one or two features, but that will end up, maybe your classification may be wrong. So what we do is ultimately we go for higher features, right? So when we go for higher features, it has another implications in machine learning. So what we try to do is we try to reduce the dimension of the feature, right? So that's one of the common, one of the terminology is the curse of dimensionality reduction. The curse of dimensionality reduction means that as and when we increase the number of dimension, other things pop out. You may end up classifying correctly, but a lot of other things at the end, at the back, lot of other things pop up. So we try to reduce the dimension, and basically these latent variables reduces that dimension. So it helps in dimensionality reduction also. Now, autoencoders. I talked about the autoencoders. So autoencoders means it's basically two structure is there. You have an encoder structure and you have a decoder structure, right? So encoder will encode the data what you have. Decoder will decode the data what you encoded to some form. So you have an encoder and you have a decoder, right? So you have to encode this data and it decoded into this form. So this is something hidden, about this person, right? What is his skin tone? What is his gender? Beard? This is all these things are hidden, right? So these hidden attributes are basically your latent attributes. So